Hi, I'm Mike, one of the co-founders of Tikos, and I'm going to give you a quick technical overview of our product. Okay, our goal is to help developers in enterprise teams build safe, smart, and compliant AI systems. So, in order to achieve that, we provide them with tools to ingest data, structured and unstructured, then to build out the core assets such as schemas, fine-tuned base models, and knowledge graphs. And then lastly, tooling to help them run those applications in production. The developer experience itself is primarily through software development kits in the major languages and its administration through the platform itself. So here's a couple of screenshots from the platform. Hopped ahead, let's come back. So in the platform, there are overview of metrics, number of apps that are in production, number of API calls in the current period, user management, that kind of thing, and then the actual functional parts of the platform itself, which is building systems, running systems, and then managing them. So in the build stage, here's an example of connecting to a data source. So here we are connecting to an S3 bucket. We're configuring that connection, and then we're processing all of that data into the knowledge graph. So the knowledge graph is our primary data store for the Tikos platform. Once the data's in, then developers can build things with it in the studio, and there are off-the-shelf pre-configured modules enabling all the main types of functionality to do so. So that's a very quick picture of the platform from a higher level, but I'd like to focus on where our product and offering is unique and how these features help deliver our promise of enabling safe, smart, and compliant enterprise AI. So there's a huge issue with Gen AI. Foundational models make things up. This is kryptonite to adoption in business settings, obviously. Users lose trust and compliance teams just won't sign those applications off. So our solution, which effectively eliminates those hallucinations, does a few things. And if I use this very simple example here, very straightforward Q&A, asking for the address for a business. So we get the answer as any chatbot will be able to do, but additionally, we're providing developers various endpoints so that they can stand behind those outputs. And there are three endpoints here. Firstly, we've got the hard data points which were pulled on to generate the output. So in this case, the entities and relationships from the knowledge graph. So that data originates in source documentation. You can trace it all the way back. We've got a reasoning, so understanding how the output has reasoned the answer from that source data. And lastly, an interactive graphic of the subgraph, part of the graph, the knowledge graph, which generated the answer. And these have got hyperlinks down to the source data, so users and developers can drill in to see exactly where that source data has come from. So under the hood, we use two proprietary innovations, and I'd like to just give a bit of an explanation on both of those. The first one is sequential collection. This is a knowledge and experience retrieval and adaptation system. It allows developers to build higher value applications, basically. So rather than just have chatbots that answer who, what, when type questions, we're allowing a higher value interaction. So understanding how something happened, why it happened, presenting causal reasoning in those answers. So armed with those, obviously the types of systems that can be built are worth more to users and therefore to the business. They also open up various other types of functionality, such as process automation and agentic systems. So it's a really interesting area. And if you'd like to read some more about that, we've got a white paper on our website which does so. And the last slide is on the other innovation we have, which is Synapse's Logger. This is a neural network architecture, and the purpose of it is to capture the data from the model fine-tuning process. This information is then available for developers whilst they're building applications for debugging and fully understanding outputs. And crucially, they can be compiled into reports to satisfy compliance teams and regulators. So essentially, we are solving that black box problem that neural nets have, and particularly within LLM um, applications. And we're solving that explainability problem. So I hope you've enjoyed the overview. Please reach out to me, Mike, if you'd like to learn more. Thank you very much.